Hi everyone, in today's challenge we are going to solve this problem. The problem name is combinations and the problem number is 77. Alright guys, so first of all what we are going to do, we are going to clearly understand the problem statement first of all. After understanding the problem statement, then only we will move to the logic part, and in the logic part we are going to see how we can solve this problem, what is the logic we are going to use to solve this problem. So after understanding the logic part, then only we will move to the implementation part, and in the implementation part we are going to implement our logic in Python, C++, Java and JavaScript programming language. Fine guys, and guys, if you want to have a look on the solution, which I am going to write in this video for Python, C++, Java and JavaScript programming language, I will share the link in the description. You can go through that particular link and you can find all the solution, right? Fine guys, now let's see what this problem says. So let's understand the problem statement. So guys, problem says given two integers n and k, return all possible combination of k numbers chosen from the range 1 comma n. So guys, we are given two integers first of all, right? N and k. That makes sense, right? So now what we need to do, we need to find all the combination of k length from the given range, from the range what 1 to n, from this range, right? We need to find all the combination of k length from the range of 1 comma n, right? And let's take a first example only where n was 4 and k was 2, right? So now here what we need to do, we need to find all the combination of two length, right? We can say all the combination of length 2 from the range of 1 to 4. That means number 1 2 3 and 4. So we need to find all the combination of length 2 where the number could be 1 2 3 and 4. I hope it makes sense, right? So this was the simple problem, right? We just need to find all the combination, and you may return the answer in any order. That makes nothing but guys, as you can see in the output, we have this like this order, right? 1 2 1 3 1 4 2 3 2 4 2 3. But that doesn't mean that you need to return the answer in the same order only. You can return answer 1 2, then 3 4, then you can write this, then this, but your answer should contain all the combination, right? That makes sense, right? So you can return answer in any order as well. Fine. Now let's see the examples, then try to understand this problem in detail, right? So in the first example, you can see we have 4 and 2, right? So now what we need to do, we have this range 1, 2, 3 and 4, and we have a k is equal to 2, means the length should be 2. Fine. So what we can do, we can find all the combination, right? So the first combination which we can see manually, that 1 2 is the combination of two length, then 1 3, then 1 4, right? Then we can say 2 3, 2 4, then we can say 3 4, right? And we can write in the next line because it's 3, so 3 4, right? So these are the, we can say, 6 combinations we are getting of len 2 from this given range 1 to 4. I hope it makes sense, right? So same thing they have written in the output as well, 1 2 1 3 1 4 2 3 2 4 3 4, right? I hope it makes sense. So now let's see the second example. The second example, we have n is equal to 1 and k is 1. That means there is only one number, range is only this, and we need to find a combination of length 1 only, right? So we can, what we can do, we can simply written this one only, right? We can't find any more because the range is containing only one number, and we have to find a combination of one length only, right? So we are returning simple one only. So this was a simple problem, guys. I hope you understood the problem statement. We are just given n and k. We need to find all the combination of k length from the range of 1 to n. That makes sense, right? Now guys, let's move to the logic part. See how we can solve this problem, right? So to solve this problem, we don't need to learn anything else except the recursion, guys. Just we are going to learn a recursion concept here. So let's see how we can solve this problem. If you know recursion, you can easily solve it. You don't need to worry about any other part. You are not going to use any other algorithm except the recursion, right? So what we can do here, guys, we can say how recursion going to work first of all. Why we need to think about recursion only here, and can you find any pattern here? So I'm so far I can see one pattern, that is take or no take pattern. And why I come up with this, just let me tell you this particular part, because in first example I was having this range, right? And I noticed that, guys, I am taking 1 comma 2, this one. If you focus here, I'm just telling you here how we can use to this particular approach and how we can use this approach, right? So we have this one, right? So I have mapped with these two, right? You can see 1 to 2, and I also map this one with 3 as well, right? 1 to 3, and I also map this one with 4 as well. You can say 1 to 4, right? This means nothing but we can say with this, nothing but we can say 1 can map with 2 3 and 4 as well, right? Same for 2 as well. So this was the 3 combinations. Same for 2 as well. So this 2 can map with 3 and 4. This 2 can map with 3, so 2 comma 3. This 2 can map with 4 as well, 2 comma 4, right? And same one more thing is nothing but we can say this 3 can map with 4 as well, right? This 3 can map with 4 as well. So what we can see here, guys, we can say they are not mapping with the previous one. 3 is not mapping with the 2, right? Because 2 has already mapped with 3. You can see this here, right? And same 2 was not mapping with 1 because 1 has already mapped with 2, right? I hope it makes sense, right? So we have seen how we get all these 6 combinations in the first example, right? Simple thing, guys. 1 is going to map with all the numbers which are ahead to it, right? Second is also going to map all these numbers which are ahead to it, and third is also going to map with all the numbers which are ahead of it, right? Simple, makes sense, right? But how we can do with the code, right? So is there any approach which we can use? So let's understand the recursion tree first of all. So guys, I'm going to make a recursion tree which will make a little we can say bigger, make sense, right? So recursion tree is going to depend only on current, and we can say key. These two variable is going to keep changing in our recursion tree, except the rest of the variable will remain same, right? Fine. So let me write here first of all my range. I'm just taking a first example only, right? So where n is 4 and k is 2. So my range is going to be 1, 2, 3, and 4, right? It makes sense, right? Fine. So let's I need a more space here. So let's write here this recursion tree here, right? So I have current, I have k. Now try to understand over here. Current is going to be nothing but what? So I have this array 1, 2, 3, 4. This range, right? So I'm going to say starting from the first index. This one, starting from the 1. So let's remove all these things and let's write here from current is going to be 1 and k is going to be nothing but initially 2, right? Both are this. So I'm going to start my recursion now. So let's see what we can do with the recursion, right? So what I'm going to do, I'm going to say either you can take this number, either you cannot take this number. Don't take. Makes sense, right? So if I'm going to take this one, so where I will reach to now? If I take this one, so I'm going to move to 2, right? That makes sense, right? If I'm taking this number, I will move to 2 and my key will decrease by 1. Why? Because now earlier my array was empty, but now my array will have a one number. Why? Because I have taken one number, right? But if I don't take a number, if I don't take one number, so I'll anyway move to the second one, right? I'll move to this 2, but my key will not decrease because I haven't taken any number. Key will remain same, and this array will remain empty. This array tells us that what is the numbers which we have taken, right? That makes sense, right? Fine. Now let's move ahead. So what I'm going to do now, guys, I'm going to say from this 2 comma 1 again, either you can take it or not take it, right? Simple. And here also you can take it or not take it, right? Simple, makes sense. So if I'm taking a 2 comma 1, if I'm taking a 2 number, second number, so I will move to 3 1. Fine. And k will reduce to 0. It makes sense, right? K will decrease to 0. And so my array will now 1 comma 2. 1 earlier was there. Now I have taken 2 numbers, so I will append this. Now my array will have 1 comma 2. And if I don't take it, so I will move to 3 anyway. But my k will not reduce. K will remain same. And array will also remain same, which is nothing but 1. Right? It makes sense, right? And same goes here. If I take it, I will move to 3 and k will decrease by 1. So 3 comma 1. And if I don't take it, so I will anyway we will move to 3, but k will not reduce. It will remain same. And my array for this will remain same, and this will contain 2 because we have taken a 2. Right? It makes sense. Now I will move ahead and I can say here. So here, guys, before taking or not taking, I am checking it whether my k is 0 or not. If k is 0, that means I have taken a sufficient number. I have an array of the given length, right? So what I'll do, I will say this is my result. This is my result array. So I will append 1 comma 2 here, right? And I will not proceed now. It makes sense, right? And in this part, what I'm going to do, I'm going to say, okay, here k is not equal to 0. So what I can say take it or not take it. So if I take it here, so I will move to 4 and k will reduce to 0 because it will decrease by 1. And my array will be nothing but we can say 1 comma 3 because I have taken a 3 number. So I'm going to append 3. But if I don't take it, so I will move to 4 anyway, but k will not reduce, right? K will remain same and array will also remain same, which is nothing but 1. Fine. Now let's move ahead. 3 comma 1. So if I take it, I can take it, right? So I'm going to take it and I will move to 4 and k will reduce by 1, which is nothing but now equal to 0. And my array will be nothing but 2 comma 3, right? Because I have taken a 3. But if I don't take it, then I will say I will move to 1 4 and my k will not reduce. It will remain same 1 and array will also remain same, which is nothing but 2. Fine. And here also we can say two choice, either you can take it or not take it, right? So if you're taking it, so what you are getting, if you're taking, you will move to 4 and you can say k will reduce by 1 and you can take it, so you will get in your array 3, right? Fine. If you're not taking it, so what you are going to do, you're going to say move to 4 and note k will not reduce, k will remain same 2. And what you can say your array will be empty initially. Fine. So now move ahead. So you can see, guys, here k becomes 0. So we are not going to proceed further, but we are going to add this 1 comma 3 in our result array. So I'm going to add 1 comma 3 in my result array. Fine. And next move ahead. So here what I'm going to have, I'm going to say 4 comma 1, k is not equal to 0. So what I'm going to say, I can say take it or not take it. So if you can take it or not take it. If you're taking it, so we'll move to 5 and k will become decreased by 1, which is 0 now, and your array will be nothing but 1 comma 4. All right. And if you can say if you are taking it and not taking it, so we will move to 5 anyway, right? So let me change the color. You will move anyway to 5, but your k will not reduce. It will remain 1, and you can say array will be nothing but 1 only, right? Fine. And here you can see here we cannot take it, right? So we can say k, we found k0 in this part, so we can say break. We are not going to proceed here, but we are going to add this array 2 comma 3 in our result. So 2 comma 3 is here. Fine. And now what we are going to say, fine, it makes sense. Now we are going to move to ahead. So 4 comma 1, right? So we can take it or not take it because k is not equal to 0, right? So we can say take it or not take it. So if I am taking it, so I will move to 5 and 5 comma 0. Why? Because it decreases by 1 and my array will be, earlier was 2 and 4 is going to append here, 2 comma 4, right? And if I am not taking it, so anyway I'm going to move to 5 because I will increment by 1, but 1 is going to be remain same, k will not reduce, right? 5 comma 1 and array will remain same 2. It makes sense, right? It's going to be 2. Fine, this makes sense. Now let's move ahead. So here's 4 comma 1, right? So either I can take it or not take it, right? So if I'm taking it, this 4 comma 1, so what I'm gonna get? I'm gonna get 5 comma 0, and my array will be nothing but 3. Earlier was 3, and I'm gonna append 4 because I have taken a 4. If I don't take it, then what I'm gonna say? I'm gonna say anyway I'm gonna move to 5, but k will remain same 1, and array will also remain same, which is nothing but 3 only, right? Fine. And the here the last one, 4 comma 2, either I can take it or not take it, right? So I'm gonna say I'm taking it, so I will move to 5, and I'm say reduce by 1, so it will be now 1 is 1, and I can say I have 4. But if I don't take it, so I'm gonna say anyway I'm gonna move to 5, but k will remain same 2, and empty array is also remain same, which is nothing but 2 only, right? No 2 is empty, right? So this is nothing but the last part, right? Now let's move ahead. So I'm gonna move ahead. So I'm gonna say, guys, here 5 comma 0, right? So you can say you found here k is 0, k is 0, that means nothing but we are gonna say we are not going to proceed here, and we are going to append this 1 comma 4 in our result. So we are going to say in result I'm going to say 1 comma 4. I have written 1 comma 4. Fine. And now here you can see in the next part we have not k is equal to 0, but here we can't take it or not take it also. We cannot move ahead. Why? Because our current, this is not even, we can say our current only, right? So 5 was current only. So I have told you, let me just go over. So here this was nothing but current comma k array, right? So current comma k, this was only this recursion part, right? So when current is greater than our given n was 4 only, right? N was 4 only, we can include only 1 2 3 this number only, right? 1 2 3 4. So we cannot include 5. So I hope it makes sense. We cannot include 5, right? So we cannot include 5, so we're gonna say break this particular recursion as well, right? So we are not gonna proceed further. So here you can see k is 0. First of all, we are checking k whether it is equal to 0 or not. So you can see k is 0, so we are gonna say append this particular 2 comma 4 in our result, 2 comma 4 in our result, right? So you can say we are going to not proceed here, right? Then first here also we are going to check, first of all, k is not equal to 0, but we also have to check the current. Is current greater than n or no? Yes, current is greater than n, so we are not going to proceed here. So whenever k is equal to 0, so we are appending that data in our result array. Whenever current is greater than n, we are not appending any data, we are directly breaking it, right? Fine. Here you can see k is 0, so we are going to append first of all 3 comma 4 in our result, then we are going to break it, right? So then we are going to break it. Fine. Here you can see k is not equal to 0, but current is greater than 4, so we are going to break it. Here also we are going to break it because current is greater than 5, greater than 4, and here we are also going to break it, right? So you can see, guys, there is no more recursion left. So we have come out to our main base case. So we have written all these cases, and we found our result that which is nothing but, so let me go above. So you can see, guys, we got a result which is nothing but 1 comma 2 1 comma 3 2 comma 3 1 comma 4 2 comma 4 3 comma 4. So this is nothing but our answer. You can see in the output as well, we have 6 length of an array, right? So this is the same answer which we are going to return. So same thing after recursion over, you can simply return your result. I hope, guys, finally you understood the logic part, right? Simple thing, we can either take it, we are not taking it. If we are taking it, so we are moving current 1, k minus 1. If we are not taking it, then we are moving current 1 anyway, but we are not doing a k minus 1, right? Same thing, right? And if we found k 0, then we are appending that array into result. If we found current is greater than n, so we are not appending anything to result, but we are breaking directly, right? Fine. Now let's move to the implementation part, and let's see how we can implement this in 4 programming languages. So guys, I am first of all with Python. So how we can implement this in Python? Simple thing, guys. We are going to say define source. And what were the recursion? Current and k, right? Simple thing, right? And we are making two conditions. First of all, we are checking if k is equal to 0. So we can say result dot append. So let me write here result. First of all, result append. And here what I'm going to append? I'm going to append my list array, right? Which was going there. So I can say array also I need to take its soul. And I can say my result is initially empty, right? Fine. Now I'm going to append this array in my result. So I can say array like this. Why? Because I don't want to make changes in array, right? If I append this directly array, so whenever in future my array will change, this result in this result also my array will change. So I have to just write like this. Fine. So I have appended in my result. But if k is not equal to 0, if it is equal to 0, so we have appended it and written it. But if k is not equal to 0, so if k is not equal to 0, we are going to check one more condition. If current is greater than n or not. If it is greater than n, directly written. Don't need to see anything else, right? Fine. If current is also not equal greater than n, k is also not equal to 0, then we can take it or not take it. So let's say I'm taking it, taking the current. Fine. So if I'm taking it, so what I'll say first of all array dot append this particular, we can say data. So we can say array dot append what? We can append current. Fine, and we can say after that you can solve this. Solve current plus 1, we are taking it k minus 1, and you can say directly error, right? Fine, and after that I'm saying that not taking it. So what I can say, I can say if solve, you can say arr dot pop solve, and here you can pass current plus 1, k remains same, k will not decrease here. If you're not taking it, current will increase anyway, but k will not increase, right? And after that you can pass arr, right? After calling this function solve, starting from 1, k was initially k and array initially empty, starting from this we are going to return our result, right? Let's see whether it's working fine or not. And it's a simple problem, right? Just 4 or 5 line of code, not more than that. You can see both the test case passed, so let's try to submit this code, and I hope guys it will also gonna submit. So let's see. And you can see guys, it successfully got submitted, right? So we have successfully submitted this problem. Now let's move to the next programming language, nothing but C++. And here what we are going to say, we are going to say first of all make a two thing, right? First of all result and array. So we can say result is going to be nothing but vector of vector int. We can say result vector of vector, not vector of vector. Here array will be simple result, right? Not this is going to be array, right? So we have defined two things. Now we are going to call a function solve, and there we are going to pass first of all our current and k. Then we have to pass n here as well, and then result then error. Why? Because we are defining this function outside of this method, right? So here current is nothing but equal to 1 only, right? Simple. Fine. Now let's define a function void solve. It is not going to return anything, right? So what we can do, we can say simply void solve. Here we can pass current. Here we can say simply k. K is only nothing but k, and then n. Then we can say vector int, vector of int, right? Vector of int, and we can pass by value result, and vector of int pass by value, we can say arr, right? Simple thing. Now what we are going to say, we are going to say fine if our k is equal to 0. So what you are going to do, if k is equal to 0, then you are going to say in result you have to push back. What you are going to push back, you are going to push back your array, right? So you are going to push back your array if it is equal to 0. It's fine. So fine, and if k is then you are going to say return. So you are going to say return, right? Fine. And if it is not the case, so what you are going to do, you can say if our current is greater than n. So what you are going to do, if you are going to say if your current is greater than n, you can say return directly, right? Fine. And one more thing, which is nothing but we can say if current is also not greater than n and k is also not equal to 0, then you can either take it or not take it. So if I'm taking it, so what I'm going to say, I'm going to say you have to do this. So you can say nothing but you can say arr dot pushback, and you can say current plus 1, fine, and you can say k minus 1, and n remains same, result remains same, array remains same. So we have reduced k by 1 and increased k current by 1, right? Now we are going to say taking it. So we have, why I am doing this, I don't know. It's a solve, right? So we have to call this in solve, right? So before that we have to append, right? So arr dot push back, we can say this current, right? So appended this current in our array, then we have called this function, and second time I'm not going to take it, not taking it. So what I'm going to say, I'm going to say arr dot pop back, and I'm going to say solve, same thing, current plus 1, but k will not reduce, k will remain same, and result an arr. Fine, right? So now once this is done, then we are going to say return our result. Let's see whether this working fine or not. So let's try to run this code, and just give me a second as well. I'm going to do something. So you can see guys, it passed both the test cases. So let's try to submit this code as well, right? So give me a second, and you can see guys, it successfully got submitted. Now let's move to the next programming language, which is nothing but we can say Java, right? So in Java, what we are going to do, we are going to say first of all find two things. First of all, create result and array. So for creating a result, we can say simply result list of integer, and here we can say the name I'm going to give result, which is going to be new array list, and here we can say list of integer. We can say arr, which is going to be new array list. So we have created both of the things. Now we are going to call a function where we are going to pass current. First of all, current is going to be 1, then we are going to pass our k, then we are going to pass n, then we are going to pass result, then we are going to pass array. After calling this function, we are going to return result, right? So now let's define these two functions. This only one function, right? So function data type going to be void, the name is sol, and first of all we are taking current, so we can say current. Then we are taking we can say what we are taking, we are taking k, right? Then we are taking n, then we are taking list of integer. This is nothing but result, list of integer. This is nothing but we can say arr. Fine. Now we are going to say if our array, if our not array, if our k is equal to 0, right? If our k is equal to 0. So what you are going to do? You are going to simply you can say if k is equal to 0, then we can say simply append this your array in your result, right? So we can say result dot add. What you're gonna add? You can say new array list. And what you're gonna add? You're gonna add this to your we can say what error, right? So you're gonna add this part, right? After this, you can simply return it, right? So if it is not equal to 0, if current is greater than k, so what you can say, if current is greater than k, you directly return it, right? But if it is also not the case, then you are going to take it as no take it, right? So taking it current. So taking it, then what we can say, array dot add what you add current, then you're going to call this sort function, you're going to pass current plus 1, you're going to current plus 1 k minus 1, you're because you are taking it and remains same, result remains same, AR remains same. But if you're not taking it, that means not right, not taking it. So you can say array dot, you're going to remove this add, whatever you have added, you're going to remove this. So you're going to say ARR. How you can remove this? You can remove like this, ARR dot size minus 1. Once you remove it, you're going to say sol, you're going to call the same function current plus 1, but k will not reduce this time and remain same, result remains same, ARR remains same. Fine, now let's see whether this working fine or not. So I hope it should work, right? So let's see. You can see we got a wrong answer, right? So why? Let's see that part. We got an empty array. Why? Okay, we got an empty array, right? So let's see. In case 2, what we got? In case 2, we got 1, but in case 1, we got an empty array, right? So let's see what we have. Current is greater than k. What that makes sense, right? Current is greater than n, right? Now let's see. All right. So you can see, guys, both the test case passed. So let's try to submit this code. Hopefully, it should submit now, right? Let's see. You can see, guys, it successfully got submitted. Fine. Now let's try to move to the next programming language, which nothing but we can say what JavaScript, right? So in the JavaScript, what we are going to do? We are going to say first of all find a length, not length. First of all, create two things, right? First of all, const result, then array, right? Then you are going to return, you are going to create array. But here you are not going to create array. Why? Because we are going to define function, nested function. So we can say const sol is going to take two parameters. The first parameter is current, then second parameter is k, then third parameter is nothing but third is also which is array, right? Fine. Then what we are going to do? Then we are going to say current if k is greater than 0. If k is not if k is equal to 0, then you're going to say simply what you're going to do. You're going to say simply first of all in result you are going to push. You're going to push your whole array, right? Fine. After that you're going to say simply return. And if current is greater than n, current is greater than n. So what you're going to do? You're going to simply return. Fine. And also if it is not the case, then you can take it. If you're taking it, then you're going to call solve function current plus 1 k minus 1 ARR, and you have push first of all ARR. In ARR you have to push current. Fine. And then you are calling this function which is nothing but solve. So you have to make a spelling right. So fine. And after that you are not taking it, so we can say not taking it. So then you can say ARR dot push, not push. You're going to say ARR dot pop, remove the last whatever you push. Then you're going to call solve current plus 1. You're not going to reduce k, but you're going to remain same ARR as well. Fine. After this, you will call this function solve. You have called function for current 1, k same, array is empty, right? For that you can simply return your result. Let's see whether it's working fine or not. I hope it should work, right? You can see both the test case passed. So let's try to submit this code as well. And it will definitely want to submit as well, right? You can see, guys, it successfully got submitted. So guys, we have done the implementation Python, C++, Java and JavaScript programming language. If you have any kind of doubt in the problem understanding part, logic part or implementation part, you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.